Okay, I think we can start. So thank you very much for your presence here. This session will talk about building digitalization and smart readiness indicators. I think this is an important key pillars for the European decarbonization, in particular because I think everyone knows that buildings are responsible for an important part of the greenhouse gas emission, but also the energy consumption. And the energy consumption that are mostly represented by fossil fuels. And so the European Commission push a lot of efforts to building renovation, and in particular way in every kind of renovation push the digitalization of buildings. Digitalization of building means that we are able to improve the control on building, improve the forecasting of energy consumption, and increase also the comfort for the building users. In this context, smart readiness and indicator are an important tool, I can say a certification that control the possibility of a building to connect with smart appliances, reduce energy consumption, control the energy consumptions, but also control the internal comfort and reduce exceed of energy when the building is not used. At the same time, smart readiness has to measure the possibility to enable flexibility. That is another important concept that the renovated building, and in particular way new buildings, have to guarantee in order to improve smart district, we are saying smart communities, etc. So the iteration with building becomes very important when we are promoting new technologies and where we are moving versus advanced the concept as smart cities and smart grids. So in this context, today we will present 4 researches, and in particular we will check how artificial intelligence driven biophilic design can facilitate the digitalization and can support the digitalization. We will check some experiences related to European projects, such as the other project that the presenter will explain. So I leave the floor to the first presenter, the Professor Yangang Xing, that will present artificial intelligence-driven biophilic design, enhancing well-being and inspiration in intelligent building. So the Professor Xing is an associated professor at Nottingham University, and will explain some important research in this topic. So the floor is yours.
Thank you, Michael. Thank you, everyone. How to say it sorry, right? So some mistake in the booking my flight, so I have to leave a bit earlier, but I have all the contact from my co-speakers, and then I'll get in touch with you, and if you have any questions, please ask. So today I'm just taking a liberty as a researcher working in the university. I can do something I really thinking is important, which is slightly out of the boundary of smart readiness indicator, which is missing, I think, from smart readiness indicator. It is great looking at ventilation, energy management, but how about health and well-being? So whether we can, using digital tools, to assess how smart the building is in terms of well-being. So it's just trying to present a few papers we currently working on and publish. Sorry, slightly different from traditional smart readiness, but hopefully it's making sense. So the first paper we published is looking at the impacts of built environment on your mental health, stress reduction, attention restoration, mood, creativity, and inspiration. So we collected about 300 survey questionnaires and testing using psychological metrics: relaxed, irritated, attentive, fatigue, self-assured, threatened, inspired, and downhearted, and see whether the built environment will have impact on psychological kind of state. And we going through stress, so there's a mass test and noise, and after people sat in the computer, they will hear the sound, and then we collected the base mental health status, and then we exposed randomized these four levels of building environment. So level 0 is no nature, no view windows, and very static, minimalist. And then the second level, we do have different color, different shapes. And the third level, you have more views and some artwork. And finally, the level 4 is more biophilic and more nature. And then collecting the mental status. And based on this survey, we found, which is quite interesting, you can see from level 0 to level 3. Level 0 is no biophilic, level 3 is full biophilic. And then the 4 biophilic theory, recovery, attention, refuel, and respiration, you can see basically is linear trend. When people exposed to different built environment, people do feel much kind of improved in terms of their mental health, which is quite interesting. We also look into personal differences. The people have different psychological traits, ADHD, for example, autism, and we also look at nature relatedness, how related you are to the nature, and then we couldn't find any very strong correlation between any of these personality traits to their mental impact. But we do find a cluster. So cluster 1 and cluster 5 is 2 autistic traits. So hypersensitive and hypersensitive do react to built environment differently, which is quite interesting. And we also collected mental status using EEG. There are 34 channels collecting electrical signals from different parts of the brain. And since we identified the different ways to categorize your mental state, since we identified the theater ratio, which is an indication of how inspired you are, how excited you are. So there are some this is different from self-reporting, which is more kind of physiological impacts. And then next project, we also look at AI curations and how AI can categorize different paintings or designs, and then the features of each picture, for example, like you have sea, view, water, forest, urban buildings, animals, and then those are correlated to a survey we did mental health. So which features are more strongly related? For example, the sea strongly related to stress or relax, and then based on that correlation, we recommend the picture and then measure the mental state after the recommended display. So we have 2 control group. One is based on our recommendation system. We thought this feature will affect the mental state in that way. Another is randomized. So there's no logic, it's just randomized display. And then we found 2 four very interesting significant, which is on the recommended system. So p-value is 0.002 is inspired and amazed. So that sense, your recommended system definitely working very well in that well-being aspect, which is interesting. From AI, we are thinking which part of pictures can drive to that mental impact. So we can see, for example, especially the on the right bottom line, with this green color indicating a strong correlation with sadness. It's very interesting. You see picture on the left. Human need some time to think why that is sad, and then AI can pick it up very quickly, which is probably interesting. Another project we're looking at real-time feedback. So people, when put into their lecture theater like this, and then collecting their mental state. If the people have public speaking anxiety, and then the brain signal will tell the person in stress, and then play some music or breathing exercises, try to regulate people's mental state, which is quite interesting, new kind of real-time changes. In terms of AI driving, so we also looking at something more related to healthcare for aging population, so fall detection, urinary tract infection, which is something related to lack of fluid intake, and dementia risk, change the behavior, for example, wandering at the doors or open the fridge, kettles, different time of day, and then we also look at indoor environment. So this is something we try to develop based on smart building, and see how the smart building can help people live more independently. So something we collecting data, and then one thing we're currently working on is to see the activity, daily living identification by monitoring different devices, and then that can be linked to people's kind of daily activity, and then this can refer back to your diagnostic, for example. We're also collecting some variability. So it's quite different from building services, but we're also trying to say how the environmental design or environmental condition affect people health using wearable sensors, and something which is interesting for different fractal level, with more complex environment will have significant impact on mental health. We're really interested in the quality of future. So this is the indication, for example, the high fractal and low fractal, or medium fractal. High fractal will have more zoom in to see leaves, for example, and then those pictures are different in terms of impact on mental health. We also did Shenryoku is forest basin in the hospices for end-of-life palliative care, and then we see the forest basin in the nature environment definitely have a significant impact on mental health. And also in terms of design, so we're also looking at different pathways affecting people's mental health in the hospices. And this one is related to a heritage building. Some of you might work in heritage building. So this is a chapel hall, Whitehall area in London. From the picture taking a drawing 200 years ago, more than 200 years ago, you can see soft furniture, curtains, and the seat covering. And then this is all in current state. And you can see those different designs will have slightly different impact on mental health in terms of thermal comfort and then other related sections. So this is probably last picture I want to show. After we collected smart readiness of building, we're also interested to see how the behavioral impact well-being. So that is something we try to develop behavioral change from experiences to cognitive, emotional, and ethics, different pathways to change people's behavior. And currently, I'm chairing 16 intelligent building groups. We're developing a handbook for building services engineer, facility management, see how the mental health, also the smart readiness will improve the building sustainability. And the CIB is an international organization, is a UN-related organization. I think started from France, I think, but there's a different working group 098 is on intelligent and responsive building. We're also organizing international conferences and webinars through these two industrial organizations. 60 is a UK-based Institute of Building Services Engineering. So RAVER is a EU kind of umbrella for all the different building services, heat ventilation. So we're working through these two organizations, try to collaborate more. So I'm happy to get in touch with you and see how we can work together. Thank you. How to leave that next meeting. Thank you. Any questions? So any questions like that?
Yeah. Considering that the Professor Xing have to leave the paper section, if you want to ask some question, we can do now, and then leave. Yeah.
I have a quick question. It was very interesting. I was wondering with you've done a lot of work with actual building users, and so even going to asking, and even with sensor measurement of personal things on feelings, emotions, and so on, did you get any pushback from people in terms of sharing like personal, impressions and their personal emotional state?
We do have ethical approval.
Okay.
So before they participated, we explain what this experiment is, and then you can withdraw at any time, so they are aware of their rights. But we don't think we have pushback. So in our recruitment strategy, we just saying the two type of recruitment. We're not really trying to push and promoting the benefits. So we just have a poster simply to say what is the experiment about, what is required. If you're interested, you can participate. I don't think I had the pushback, but when we designing the questionnaires, one task, potentially we try to see the cognitive task, how fast you can do math calculation, for example, and then later on we discarded it, probably for member of staff or students there. They don't want to show their weakness in that, so we kind of have some consideration. But all the participants are fully aware what is required, but they can withdraw at any time. Yeah, it's very important to concept.
I think even I'm interested in terms of then the application, in the real world, when you actually go and then use these insights. If you need to look at people's emotions, it may be hard to get that buy-in and say like we need to monitor.
I totally agree. Yeah. So that's something we not really possibly collect all the people's responses, but we have sample and we know what his potential is, so we don't have to ask people's feedback all the time.
Thank you.
Thank you. Cheers. Thank you.
So you're training AI to recognize human emotions. How would that affect the human future?
Yeah, it's very interesting question. It's a human future in which way?
How would we recognize then what is a real human and a artificial intelligence in the future? Well, we have seen all these movies.
Yeah, for example, we develop AI prediction tools, and then And then we thought, yeah, if the AI can predict very well, and then what is about us is really quite interesting. But whatever we're trying to regulate, AI will be there. It won't go away. So that is what we thought is how to use it more ethically, and it is even human creativity need to be protected. That's for sure. Yeah.
Thank you.
Thank you.
Other questions?
Thank you. Thank you.
Thank you very much. So the next presentation will present some activities related to the Smart SRI to Market project. The presenter is Dimitris Fotopoulos. Please correct me if the pronunciation is not perfect. He's a researcher at TESS Lab, that is a Techno-Economic and Energy System Laboratory at the University of Piraeus in Greece. So the presentation, the project that Nils will present aims to facilitate the acceptance of SRI at national level. Thank you very much.
Thank you, Marco. So yeah, guys, the event has been really already heavily SRI revolved. This, however, complements the other things that we have already talked about the past few days. So we're getting a bit more technical, and we are actually bridging the gap between the SRI and the benefits that it brings for buildings. So just this is Mr. Young's presentation. Yeah, this is it. So a quick few words about the SRI. So it actually measures how smart the building is. And it does that by actually breaking down the building into technical domains. So you have like heating, cooling, domestic hot water, so on and so forth. There are 9 technical domains. And then each technical domain actually has services to it. And then each service also has some functionality levels. So for example, let's say I have an example here of the electric vehicle integration. You can actually have at the first level a simple EV charging. At the second level, you have like a cost optimized charging based on grid price signals. And on the third level, you can have like a bi-directional flow of energy between the building and the vehicle. So yeah, but so as you would imagine, as you go up at the functionality levels of each service, the SRI score of the building actually increases. But that percentage doesn't actually correlate to actual savings. So the question that we are asking, we are actually trying to find a correlation between the actual benefits that building stakeholders enjoy, like landlords, property developers, occupants. I mean, how much will they cut down on energy costs? So to explore this question, we developed a tool, a quantification tool that models a building and models various services within the technical domains that I mentioned earlier. It involves various parameters. You can see some of them on the right. And we see value in it because it first, as I said, it correlates cost benefits with a SRI score, and that helps users actually see the value in it and adopt the SRI framework. So it's going to help with its diffusion with it. And also for SRI practitioners like examiners or even simply users, they can also test what if scenarios. So what if we install a battery, let's say, or what if we install a smarter energy management system. So yeah, so in this presentation, I will show you the application of this tool to one particular service within the electricity domain, which is called storage of locally generated electricity. So these descriptions, don't bother reading them. They're actually from the SRI official catalog. But on the next slide, you will find a much more digestible version of them. So the setup is as is on the right. So the building can either, it has 3 ways to cover its energy needs. You can either do so by the grid, Or it can do it by drawing energy from the renewables, on-site renewable generation, which can be either consumed at the time of its generation, or stored for later use in the building's battery, in the building's energy storage system. And the three levels, actually, it's the management of this battery. So at the first level, we use the battery and the renewables as much as possible. So it's like a simple self-maximization algorithm. At the second level, we actually get external data regarding the grid prices, and we compare the price, the levelized cost of energy of the renewables and the grid, and we choose the cheaper option. And at the third level, we have forecasts, day-ahead forecasts regarding grid prices, renewable generation, and the building's demand. So the algorithm can actually balance these three energy flows to the cost optimum. So to test this tool that we developed, we actually did it to 4 different buildings. The 4 different buildings are 2 commercial buildings and 2 residential buildings, a hotel and office, single-family house, and a multi-family apartment building. And these are just to show their specifications regarding their floor space and their installed capacities for their solar photovoltaic panels and their batteries, their energy system storage. So let's go. Small tribute to all the data and the sources that we used to create this model. So let's talk about a bit the results. So we will be seeing at the next few slides the percentage cost reduction as we move up in the functionality level, and especially for the residential buildings, we will do that under 2 different pricing schemes. So the pricing schemes are going to be constant prices and dynamic fluctuating prices from the grid. And we did this because, according to the French government, residential buildings actually do pay a constant fee for the electricity. However, the SRI descriptions, which we did not read earlier, they imply a fluctuating grid price. So we tested both, at least for the residential buildings. So we're going to start with this. And as you will see, so this is the first level, which means no storage available. And after the first level, we have storage, and the second and third levels are the smarter functionality levels. But as you see, for both these buildings, for both these residential case studies, the cost reduction remains flat after the first level. And why is that? Because levels 2 and 3 actually make a comparison between the grid price and the levelized cost of energy. But if these 2 values remain constant, then the comparison result will always be the same. So that's why we do not see any further reduction in the cost as we go up in the smartness level. So this is under flat rates, meaning a constant price. But a different story when dynamic rates are prevalent, are existing in the house. So we see a progression as we move up in the functionality level, both for residential buildings and commercial buildings, costs drop. However, you see a clear trend. There is a difference. I mean, it looks like residential buildings have a better capacity to lower their costs, while commercial ones are like they see a modest decrease in costs. So this has to do with 3 things. It has to do with the demand profiles of the buildings, it has to do with the renewable generation profile, and also has to do with the grid price fluctuations. And I'm talking throughout the day. So let's have a quick look. These are a typical daily consumption pattern of our houses, buildings, apartment buildings, and single-family houses. So you see, highlighted, there are like 2 peaks, one in the morning and one in the afternoon. And bear in mind, you will see later, about 3 slides later, these align really well with spikes in the grid price. Let's move on to the commercial buildings. These buildings, as you see, they have the opposite. Their peak is in the middle of the day because people leave their houses, they go to work, so the consumption is mainly gathered there. And this, as I say, is really aligned with the renewable energy generation peaks, which we'll see in this slide. Of course, when the sun is shining, solars produce energy, and this tends to happen in the middle of the day. So if you compare the two, those two peaks are really aligned. And what this means is that generation and demand in commercial buildings is really aligned. So there is actually no big need to move energy from the middle of the day and to the afternoon, because in the afternoon, the demand for energy decreases. But as we saw earlier, the opposite is true in residential buildings. These are not in sync. So that is why in residential buildings, they have a better utilization of the battery. Now, combine this with the grid prices, you can see the grid prices actually align really, really well with the peaks of demand in residential buildings. So this further increases the need of transferring energy, storing energy for later use in residential buildings. And this is why we saw earlier such a greater cost reduction in those buildings. The part about utilizing the battery better can also be seen from these pie charts. The blue part symbolizes the energy that was drawn from the battery, while the green part symbolizes the energy, the renewable energy that was consumed the moment it was generated. So you can compare both horizontally between single-family, multi-family, meaning residential and commercial case studies, that residential case studies tend to have a bigger part of the blue. And you can also compare from top to bottom between level 1 and level 3, that as we increase in the functionality level, there is also a better utilization of the battery. So yeah, some conclusions. So we saw the difference between the typologies. So residential buildings and commercial buildings do utilize the batteries differently. One, residential buildings tend to have to draw more value from having an energy storage system in place. And we also saw the importance of the role that pricing schemes play. We saw in the first slide of the results that the cost reduction stagnates if we have flat rates in place. So market regulations and the market and the tariff structure must go hand in hand with smart readiness. And lastly, we talked about the level 3, which under the dynamic rates had the best performance. And this relied on forecasts and data. So we need data and we need interoperability, we need interfaces, we need APIs, we need to find ways to gather clean data, and we need to find ways to share this data in an efficient manner in order for this smartness level to actually work and provide value for both buildings, for both commercial and residential buildings. Lastly, we have planned some next steps out. I was already talking about the paper that we're planning to publish on this tool. We want also to extend the tool. We want to model new domains, new services. We want to explore cross-domain synergies and cross-service synergies. We want to further develop the tool and make it available to SRI examiners in the upcoming SRI implementation phase that the EU has planned. And lastly, there is also an idea is out there to extend the SRI from the commercial buildings to the industry, which is really energy intensive, as you all know, to unlock further value. So that's about it. Thank you, guys. Any questions? I'd like happy to answer if anyone. Yeah, please.
Excellent work. Thank you very much. I did not get how you account for the flexible demand management, so the load management in the level 3. I assume you are not taking into consideration. And if that is the case, my second question is, would you consider having level 4 when you actually communicate with the load management?
Okay. So yeah, load management means demand side management, like shifting loads.
Yes.
This is actually part of another service. So it wouldn't exactly be level 4 because this service is about the storage. But within the electricity domain of the SRI, there is another service, a whole other thing with its own levels, which is about optimizing the loads of the building. And we have actually done some work on it, but then the presentation would be too lengthy. So this is why I did not include it. So the thing that you're talking about is also another thing completely, but also part of the SRI, and it's really interesting to look at. And we have looked at it.
Okay, but you are saying level 3 takes into consideration building demand.
Exactly.
Building demand is actually influenced or actually impacted by the load management in the building. So if you don't take it into consideration in this smart ready service, then it's not going to actually reflect the real functionality of a smart building. Because you stop there, you basically look only at the outdoor conditions, if I understand correctly.
No, I mean,
So the building demand, how do you calculate or take the building demand?
for the modeling purposes, we go through a lengthy process to build these time series. But the level 3, in order to work, this is a modeling work. So the level 3 work, we would need a prediction algorithm. So a time series prediction algorithm to actually predict the next day's building demand. And you would do that.
Based on what? Based on weather conditions?
Not based on weather conditions, but rather historical data. This is the way that I would model it actually. Historical data. And maybe you could also include in this modeling, the weather probably would play a role in that, or the seasonality. Yeah.
Okay.
But that's work to be done in the future.
Okay, good.
But a really great idea, and
Okay,
future work.
because many of the other services are actually the higher the level, it is the communication to the brain of the building that is giving the higher level, the highest level. So if
the biggest
this
impact.
part of the service does not communicate to the other part, then you are missing an opportunity.
Yeah. We have to consider that in the
Okay.
further development. Thank you. That's it, guys.
Other questions? I could make something like a remark. Have you any values from the economic nature of this problem, let's say? I mean, when I install a battery and I also apply some control in order to increase the SRI, how much money should I give extra and what should I expect? Like
Payback period.
A payback period or whatever. If you have done it, okay, this would be interesting. If not, this would be also interesting to include in the paper.
In the future. Yeah, we have not actually included techno-economic data of that kind. We wanted to model the functionality levels.
Yeah.
But that's actually really interesting way to move it further.
And the more interesting way to go for it is what should be the circumstances in order for this to be a valuable investment, let's say, the regulation framework, etc. So how you can convince people to further increase their SRI scores and install more delicate control systems on their buildings?
I think this tool would help in doing that by actually communicating the value. You see that as you go up in the smartness level, you will be expecting some percentage decrease on your costs, and that will provide the financial incentive for people to actually invest in the equipment. Now, paired with what you said, with the capital expenses and the payback period, then you would also make an even better techno-economic assessment of this investment, and probably you would convince some people even more easily.
Because in recommendation system that many of us are developing for SRI, this is a huge gap, the correlation of SRI with money.
benefits.
Let's
Yeah,
say.
we were talking about it yesterday. Yeah.
Just remarkable. Thank you.
Thank you, guys.
I have another question related to your activities. So I would like to talk about more general approach. So you explained very well the digitalization at building level, so the exploitation of energy storage, in particular lithium batteries. I would like to ask you if your research activities take in consideration also the district level, because as from my point of view, the business model have to be considered not only at building level but at district level, because yes, this is probably my perspective. I think it's very difficult to install in each building the right capacity of batteries because we need a lot of lithium in every building. It means an additional CapEx cost, and as seen in the Italian situation, so the last 2-3 years, the cost of the batteries cannot be sustainable without incentives, and sometimes people prefer to increase the size of renewables and curtail production. So your approach works well in building level, but what do you think about extend the management and optimization of batteries, considering, for example, building with capacity, storage capacity, and building without storage capacity?
That's actually yet another service that the SRI also outlines, and we want also to model that. There are so many services in SRI, so there is a lot to be modeled. I actually, I do mention it here, microgrids. This is how SRI actually describes it, as microgrids. So we want to actually assess this and maybe also connect it to EV charging, like having a wide fleet of electric vehicles that respond to grid signals, and they can discharge their stored energy. Maybe they can also work with energy storage systems of buildings, and these can be aggregated on the whole district level, as you said. But it remains to be modeled. So thank you. So great questions, great ideas for further development. Thank you. Thank you, guys.
Thank you very much. In the next presentation, we will discuss how the approach of digitalization can be extended in other kind of buildings. But this particular way, we will see the physical base digital twin comfort inside the airport terminal. So airports are an important building type of buildings that consume a lot of energy in a continuative way. This presentation will done by Giulia Barbano, R&D project manager at IES Ltd. And in this particular way, we will analyze some concept related to the STARGATE project that aims to increase the greener aspect and the sustainability of airport buildings. So thank you.
Thank you, Marco. So that was it. No. We're going to zoom in a lot now on specific spaces. I think it's interesting. We had through this session, we started from the high level and then we get to the building, and now we're actually going down to the single spaces. And this is a very interesting case, I think, because we're talking about using digital twins for building operations. I will just shortly say what I mean so we're all on the same page. But there's a specific case in airport terminals that's different from other buildings, and it's worth remarking because it has some challenges and some interesting findings on building behavior and requests that's different from your residential or commercial that we're usually looking into. And I will then shortly give you the context on the STARGATE project and say more about it later. But First of all, when we talk about a digital twin for building operations, we're talking in IS about bringing together the energy model and actual data to have an accurate digital replica of a building that performs as the digital building would under the same conditions, so that we can then use it to make accurate decisions. That is, say, the basic definition. From the point of view of the airports, there is a very specific context that is not just the decarbonization and the energy reduction that is across the board, in buildings in Europe, but airports in particular, the aviation sector, is under tremendous pressure to decarbonize. So this is something that they are working on even without necessarily regulatory requirements. It's something that comes from the airports themselves. However, they also have a very, very strong requirement to keep high levels of service for the passengers. That's the most important thing. So those comfortable conditions when passengers stay in the premises are the single most important thing in any decision making they do. So that puts an interesting challenge when you're looking at energy consumption. So from the point of view of looking at the building itself, there is the nature of terminals and airports in general is a transient type of building. You don't have constant occupancy that you can look at and model and say, well, it's an office. People are there for 8 hours. It's a house. So there is extremely varying levels of occupancy. The buildings are very complex. Every building is a prototype, yes. Airports even more so. Like the complexity of the HVAC systems in airports is outstanding. So those HVAC systems, those buildings are really one of a kind. So being able to get some insights on how the building is going to operate and have that short-term forecast really can only be done with complex physics-based dynamic simulation because it's very hard otherwise to forecast the behavior. So what we did then in the STARGATE project, our objective, and we're still working on it with, in this case, with the Brussels airport, is to build this intelligent command center for the terminal. The objective is to have a way to operate the HVAC, the main building consumption through this command center that would help understand the needs of the facility managers and support their operation of the buildings, their work, by providing augmented intelligence. So how did we do that? There were 3 main themes of work I'm going to cover. The first one is that creation of that digital twin, then forecasting the indoor comfort, that is what drives that consumption. And then finally, how we design the user interaction, which is crucial to make sure that then that insight is taken on and actually applied in the building. So the first concept is having a fit for purpose digital twin. So it's starting from collecting the data, creating the digital twin, and then validating it, making sure that it is actually fit for the specific purpose of, is it going to forecast my comfort accurately? Am I going to be able to use it to make decisions? So in the first step of data acquisition, we went through a very detailed phase of acquiring the plans, the HVAC schematics. We did a few site visits. And the most important thing perhaps is we actually collected occupancy measurements from their system. So they actually have 30-minute resolution occupancy loads. We looked at the security screening area. So if you've been in Brussels Airport, I'm sure you have, if you've gone to an easy project review, the security screening area, I'm sure you've seen it, it's a rather complex area there's 4 air handling units that serve it, and you have your queues and then your security screening areas. So there's a lot of peaks and troughs of occupancy in that area. So you may, if you've been there, you may recognize the building. That's the model. It's called the connector building in Brussels Airport. So we built the 3D model and the digital twin, and then modeled in detail the actual air handling units and their behavior. So this is with the Apache HVAC part of our VE software. The results of that we used to validate that digital twin was then fit for purpose. The first finding was that the internal gains, so the occupancy gains, were a substantial amounts. It's over 30%, as would have been expected. So the occupancy load is a significant driver. And then we saw that there were some peaks in the relative humidity in the summer. So there was some stress, occasional stress on the HVAC system. Not enough necessarily to guarantee that you need to change your HVAC system with all that costs. So it could just, we are looking into changing the occupancy and the operational rules of the building instead of substituting HVAC systems that are already there. And most of the time, they actually serve the requirements of the building pretty well. So to really look into that and looking into that optimal operations, we did three things. So the first one was retroactively, using that model, evaluate the predicted mean vote. In comforts, I'm sure most of you are aware of this, the PMV's calculation through certain parameters of the indoor space to predict what would the thermal comfort of a person in a space be. We have then used that to confirm that it was an accurate model. And then from last summer, we started running daily simulations for the next 3 days. And so that's an automated recurring analysis that we do on the indoor comfort conditions. So this was the validation itself. So it's the scale, if you can see it, it goes from -2 to +2. Like, the PMV ranges from -3 to +3, but 3 is an extreme level of discomfort. So of course we expect lower numbers, but you can see how there's a clear pattern in this. So these are the hours of the day, and this is the summer of 2023. So this is every column is a day, every row is an hour. So we see here how the afternoons are were the hottest, the most uncomfortable. And we saw some peaks specifically in September. So you see how it's very influenced by weather patterns, of course, but most of all by the occupancy. And that's something that we saw, that graph there, that is the overall data, cluster data of the occupancy of that same summer. And so what you see there is that the occupancy and let me go back, just so you can see, you can appreciate how that is in the afternoon, but the occupancy peaks are actually, the occupancy peaks are earlier in the morning. So there is some dynamic response of the building here at play. And here we have, this was the data set of 2023. So we have the line at the top is the maximum, the busiest day of the airport in the whole summer. The lower is the least busy day, and the black line is the average. So what we have then set up is we have a cloud simulation of the digital twin running every day, takes the forecast weather conditions and outputs for an hourly level, the indoor thermal conditions, and calculates the PMV for that space. And we do it on 3 scenarios at the moment that we extracted from this. So we do it for the worst case of highest occupancy, average occupancy, and lowest occupancy. Why do we do that? Because at the moment, we don't know what tomorrow's occupancy is going to be. So it's something that we offer then to the building manager, to facility manager. They know what they expect the occupancy is going to be. So we're able to tell them, if your occupancy is going to be high, medium, or low, there's going to be a risk of discomfort. That's what we're aiming at here. So this is complex. This is just the output of, just visualize the output of that recurring simulation. But just to show you that, so you see here, so the full line, the continuous line is the highest occupancy scenario. The shorter dots is the medium, and the longer dots is the lower occupancy. And so the PMV is the purple. So you see here how we see that with the purple lines, we see, and you can almost reach it here, from the highest, this was the hottest day of 2023. So from in the afternoon, there was a peak in some occupancy scenarios that was mitigated the lowest occupancy. So that's a kind of insights we started looking at. Why am I using this one? I can do it here. But as I said, the user acceptance and the engagement and the participation of the users in this whole system is key. So when, in parallel to the technical analysis, we did this entire work with the BMS team of the airport to do user research, to really define what the problem is. And there's something that we call the job to be done. So what is the actual issue that they're trying to solve to get to this human in the loop approach. So the user research had some specific goals, and we wanted to understand their needs, design an interface that would be intuitive and useful for them, so that we could give them insights they could act on. So it's not just information, it's something that you can then take and go and do something. So we did some best practices of user research, so your interviews, conceptualization, design, and then had an iterative feedback loop with the users. So basically, we got the conclusion we got to, is what I anticipated already, is that for the BMS team who manage all the systems of the airport, they want to know if they anticipate there's going to be high occupancy loads, then they want to predict if there's going to be discomfort, to proactively manage it, to put into place support situation, even opening more security rows to process passengers more quickly, to reduce the risk that will be overheating and discomfort, which is in turn bad for the bottom line of the airport. Right? So this is, instead of changing your HVAC, it's a cost-effective strategy. It is, you're just managing your existing asset better. And it also helps the BMS team be proactive instead of reactive. Instead of having, complaints come in and say, it's too hot in this area, turn the cooling on. Like, they cannot do anything anymore at that point because of how long it takes the building to react. So that was the first prototype that we designed. So to visually trying to represent those peaks using PMV values for the 3 different occupancy scenarios to try and get to actionable suggestions. It's gone through a couple of redesigns already, but I just want to show you the results on the first test run we did last summer. So this is, initially we started seeing actually that with the forecast, we could see the potential discomfort, and we could see in some cases, this was last August, that in that area, there were some, I think the red is over 1.5 PMV and 1.5. And then the orange is 1. So you could actually see that for 4 hours, for a high occupancy, there was going to be a serious risk of discomfort. But if they could manage to reduce the occupancy, or rather to process passengers faster, that would not be a risk. So that was, I think, one of the first findings, and we converted that into that visualization to put it into the IES Live interface that we had to actually generate this feedback every day and then notify them if there is such an event. So this was a first design implemented in the software, and then because it's the testing and it's still something that's in progress, we initially started notifying this to them manually. So we got that alert, and then we started telling them via email to see if they would react, because we want to also make sure are we notifying you too much? Maybe BMS managers are very, very busy people. They don't necessarily want to get 100 emails every day. So we started having this in person, like with a personal contact, so that we can follow up. So that was what we started to do. So this is still ongoing, of course, being it's a seasonal exercise. So I did a little bit more this summer. We're going to do more next summer. We are expanding as well to the border control area, which is right behind it. So those are the 2 areas where there's the most traffic. But I think the thing I'm personally more excited about is that now we're getting occupancy forecasts from them, because they have installed headcount systems with the blip. So we will actually get a day ahead occupancy forecast that we can plug in the digital twin to really see if there's going to be that risk of overheating. So, of course, the last thing is then automate the notification system when we are all on the same page on the frequency and the content of that notification. So more exciting stuff to come there, but as you're saying, this is part of a rather big project, the STARGATE project. It's one of the Green Deal projects that were funded in 2021, and it is 22 partners at 4 airports in Europe, and it has this major overarching goals of decarbonization. Modal shift is a huge one, so there's a lot of mobility, passenger mobility and so on, and the local environmental quality is also a big focus, air quality, noise, etc. So it's a big project with a number of partners. It's coordinated by Brussels Airport, but we've been now working together for over 3 years to develop all these innovative solutions and testing them. There's a lot of these pilot projects inside of the overarching program, and it's a very exciting one. So I would also encourage you to go and look at the website, because this work I showed you is one of 30 such projects across the board of sustainability and greening airports. So I'm sure you will find more interesting things about STARGATE in general. So it's my presentation. So if there's any questions.
Thank you for the perfect timing.
Was it?
If you have a question, please.
Thank you very much.
Beat you by your
Really
seconds.
good. The HVAC control in the area you were looking at, was that demand-based control?
Yes, but it is, there's a set point, and then they have a return loop on the CO2 measurement. It's also driven by the CO2 measurement on the return air. So they do have, it's not controllable as much, or rather, it's already controlled.
Depends how
As
many
much as-
sensors you have and all the rest, but okay, some level of
Yes.
demand-based.
Yeah.
And the other
So
thing
right.
is, of course, what comes from the BMS as alarms.
The relative humidity, as which we saw in the digital twin, is also in the BMS. Like, that was not a surprise to the BMS team. When we told them, you're struggling with managing the humidity in the space, they knew. It was actually validating that the digital twin was modeling it correctly. And that's also why we saw that for some specific moments of the year, the HVAC was struggling, because it matched their finding and the types of complaints they were getting occasionally from people in the space.
Okay. And alarms on the temperature?
Some, but occasional. And they had a summer where they have more issues. And this is also, I think it was 2022, it was right after. Of course, getting good data with COVID in airports has been very hard, but they started coming back to a certain level. But they started then installing IoT sensors. Instead of having it at the return of the HVAC, of the BMS, like of the extractor fans, they put the IoT sensors at lower level in the space. So that's also data we're hoping now to start getting, so that we can compare that. So because the more data we get, it's been that iterative work together in figuring out what information they had, what information should they get. So the IoT sensors I'm sure are going to give us some other very good insight here. Yeah.
So just one more sentence.
Yeah.
So actually the initial design was not optimal.
I think it was sized properly before we design weather conditions.
Yeah. But also,
But we're not in design weather condition summers anymore.
yeah, perhaps you can give this to the designers.
Oh yeah, they have it. Yeah.
They have it.
Oh,
Okay.
The initial study they were interested in to look at, okay, should we invest? But the building is from 2015. So
Yeah, the thing is that building automation comes last.
yes.
It's an afterthought.
Yeah.
And the design of the building automation probably was not optimal.
But is it worth, like, for something that happens some days a year in the summer, is it worth, throwing out a decent, like, good HVAC system for most of the year?
No, I'm not talking about the HVAC. HVAC can stay. I'm saying the control was not optimal. Yeah.
So they've been taking a lot of this outside of the project itself to look into optimizing the building further.
Okay,
So it's been an interesting collaboration for sure.
very interesting, thank you.
Sorry.
Yeah, you partly answered the question. What I wanted to ask was about validating the
Yeah.
How you went about
Yeah.
a few words.
Because initially there was almost no data, like we just had a little bit of points from the BMS and the occupancy. What we could do is validate it against those complaints and those issues that they saw. So that's why I'm keen to look at it more with the measurement data and refine it further.
And you also have the forecast data, occupancy forecast data.
Yeah.
Now, with that, are you planning to actually, instead of just providing 3 scenarios,
Yes.
run
it with the actual
with the
forecast.
actual data and
Yeah.
even more refined scenario?
Exactly.
Yeah.
So say, okay, this is your forecast for tomorrow. If you keep it like 20% down,
Yeah.
what's going to happen? Or if it increases by 20%. Yeah.
Makes
So
it
we're
way
like
to-
having relative scenarios instead of those static ones that are based on, summer 2023 was already closer to operations, but it's a bit of a rough cut compared to, okay, if you have occupancy forecast.
Exactly. Great use.
Yeah, next few months will work.
You're allowed to say which airport was it?
That's Brussels Airport.
Brussels Airport.
Yeah. No, that's what I'm saying. You may have been into this building because I think more. If you've been in Brussels to a project review, been in that space, it's a. And next time you go, you'll think about it.
Which one of the Brussels airport? There are 2 in Brussels.
Yeah, this is no, it's
The other one, the main one.
yeah, the main one. It's Brussels
Zaventem.
City. Zaventem, thank you. That's all. Yeah. If you when you walk in, it's when you go through security, and then usually for it's A pier, the one for European.
They're better though, they become better.
Oh yeah, yeah. No, we had like working with them has been tremendous. They do a lot of work on sustainability. Honestly, they've been doing a lot of work. So, and like this STARGATE was a big part for Brussels Airport to put into place a lot of their sustainability ambitions. So it's been an interesting work, something that's a really real world application of all of the things that we talk about in the conferences.
Okay, thank you very much. So the last paper was another experience from IS Software House. Marina Munot, R&D project manager at IS, will present some results from the TwinAIR project. That is a project that will present technological solution for air quality in a wide spectrum of living areas.
Thank you, Marco, for the introduction. I know you might be tired from all of the presentations. This is the last one, so I promise to keep it short and sweet, so don't worry. Okay. If you've been attending these sessions or you've been to sustainable places other times, you may know about us, so I'm not going to stop a lot on this. We've been participating in different presentations and workshops throughout these days. So basically at IES, we are focused on the built environment, and we believe that every building can be decarbonized. And we also focus a lot, as Giulia was mentioning, on promoting comfort, health, and well-being for the users. So basically all you need to know. Okay, so TwinAIR at a glance. So it's a Horizon Europe project. It's been going since March of 2022, and it will be over in 2026. The coordinator is University of Patras, and they are participating with different departments in the project. We are 22 partners from 10 countries. If you want to know more about us, you can check LinkedIn or the website. You have information there. Okay. So I'm gonna give you 4 points of what TwinAIR is about. Very simple. As you already saw in the title, TwinAIR is about improving indoor air quality through sensing, data analytics, and visualization. So up there you can see the sensor kit that was created by, it's a company that's part of the project, Smart Labs in Barcelona, they are based. And basically the installation process and some analysis that were carried out You will see later about it. So for the methodology, we try to do a combination of environmental, medical, and technological approach to indoor air quality. For that, we had our 10 pilots, and we identified 5 high-level use cases. And for that, we did that was the mapping phase. Then we did the pre-intervention sampling, and then working on the deployment of the system. That's where we focus our efforts. And now we are in the phase of post-intervention sampling to see if the recommendations and the control actions are being effective, and evaluating this analysis. So as you see here is just a couple of examples. The high-level use cases we identified were transport, education, health, residencies, and workplaces. So some of them, for example, Linköping student who said this is very interesting building, and some others that we worked on. And then for the implementation, that's where IS was working for the technical development of tool sets. We worked on 7 developments. We had the human digital twin, building digital twin, the vehicle digital twin up there. We also did some analysis with University of Cambridge on user comfort, control actions on the filtration systems, some other activities. And we also created an interface for users to know more about indoor air pollutants and how they affect their health. Okay, so just so you have the big picture. So initially, we start with air quality monitoring, indoor and outdoor. We use different ways to measure this with wearables, sensors, cameras. We also analyze the human agents with our health partners, University of Patras. And then with all of this information, obviously our goal is to do analysis and drive some conclusions. So we are able, with all of this, to create our digital twins and some other KPIs that we drive from that, because the goal is to improve the indoor air quality. So after we have done all of these digital twins, we are able to draw well-being assessment conclusions throughout recommendations, also guidelines, policy introductions from other partners. So basically here, what we worked with was the creation of digital twins. In this project, we gathered, as I mentioned, the sensor data. And with our performance digital twin, we can carry out analysis with artificial intelligence, machine learning models, and drive actionable intelligence and information for the building owners and the different users to work with. Okay, so what we did for TwinAIR. So some key points that we worked on was obviously the building digital twins. We gathered sensor and filtration systems time series data for users to be able to analyze it. With the different recommendations and control actions that were evaluated with University of Cambridge, we managed to drive actionable intelligence recommendations. All of this together is gathered in the dashboard that you will see in the few next slides. And we also worked on a pollutant short-term forecasting tool for 3 days ahead. Okay, so we worked, as you saw before, on multiple case studies. The one I chose to demonstrate our solution is ETRA Office, which is part of the use case in the workspace. So basically, our goal here was to enhance indoor air quality performance through different monitoring activities and recommendations. And the demonstrated outcomes, well, you will see now we created in the scope of the building digital twin an interactive dashboards with different KPIs to support energy efficiency and occupant comfort. So, okay. So for that, we used our IS Live cloud-based platform that Giulia was also showing some images for Brussels Airport as well. So initially, we have an overview here where we can see the building energy performance. This is going to depend a lot on the information we get from the specific pilot. So in this case, we have energy breakdown divided by different loads. We can also analyze the energy use intensity, which is how much energy you are using per square meter. And other KPIs can be derived here, but in this case, this is all we did. Then we do the indoor air quality tracking with the sensors that I showed you before. We are able to gather the data into our data management platform, and we retrieve it with another of our tools that's called iScan. And this way we can input here. So if you see the screenshots, we also have the floor plans with the sensor location. You can go through the different rooms and click on the sensor you want to expand and see the KPIs from. Actually, if you see the colors there, it's color coded. So for example, if you see red, these screenshots were taken from August in Valencia in Spain. So everything is red because all of the thresholds have been surpassed. If you see, for example, that one that is white means that right now we are not inputting data. Sometimes they are green, but in this case, everything is red because, well, there was a lot of CO2 concentration, a high humidity, and it was very hot inside of the office. Okay, so then when you click on a sensor, you can see the graphical representation of these values. So you have the data, as I mentioned, on CO2, temperature, humidity, and also particulate matter 2.5, because some of the recommendations are focused on this pollutant specifically. You can also zoom in and you can select a time frame where you want to check the measurements. So it's not only for the day, you can select 1 year, 48 hours, or even a customized time frame. Okay, we also work on including information on air purifying systems because we are applying actions on them. And so we have information on the critical hours when a filter needs to be changed. We also have information on the fan level inside a room. So if we see, for example, a CO2 level is too high, we have is too warm, whatever, we can activate and we can work on these filtration systems and fan levels to adapt to better circumstances in the room. Okay, and then after we have all of this information, we are working on connecting all of these analysis and recommendation outcomes that we are working with University of Cambridge. So we have here 2 examples, but it can be as many examples as you have for this use case. So for example, as I said, if you see the CO2 levels are increasing, it can be something as simple as saying, hey, open the window. Or even we can have a recommendation to adapt the heating and cooling temperatures. Yeah, so basically that's it. And okay, so our goal with IS Live is that we are able to offer support to people, building owners, building managers, users that don't have the technical skills to develop this analysis, but with this very user-friendly interface, they can actually reach some conclusions and make informed decisions. So that's the goal that we are trying to achieve in this project as well, and through the use of our IS Live tool. So anyways, it was just like, I left here like a question is like, do you think this could be useful in any of your buildings or the projects you are working on? And yeah, that's all. So thank you very much. If you have any questions, I think we have 5 minutes.
Thank you, very interesting. Good work, very practical. I did not catch how you're using the outdoor conditions.
The outdoor conditions are not used in the building indoor air quality digital twin because we have a tool set, and so the work we have carried out in IS is only on the indoor side. For the outdoor, there are the University of Patra's health partners and even University of Cambridge. They are doing analysis on the surroundings of the users, and inside the tool set with Patra's we have the human digital twin, and they are driving this analysis and conclusions.
So okay, I'll tell you why I'm asking, because in one of your sentences you said, you know, if the CO2 goes up, as simple as opening the window.
Yes.
However, IAQ, the indoor air quality, is very, it, is associated with the outdoor conditions. So I was expecting something like that. When I heard TwinAIR, and I saw that you're collecting from the outside of the buildings as well information that is very relevant to actually assess what is the influence of the outdoor on the indoor air quality settings.
Yeah, for sure.
And all the, all the things that have to happen, because otherwise you open the window and the IQ probably will go to the ceiling.
Yeah, and that's something we've taken into account, and we are aware, and actually like the health partners, I say health partners because the health department in University of Patras and another partner in Barcelona, they are trying to analyze, and that's the part of the analysis, like the aftermath of the installation of the sensors. We develop the tools, and now we measure again. And now they are trying to derive this analysis, but I would say that the technological partners, we are not that focused on this analysis because we don't have the capability to analyze the whole picture. And that's something they are doing with the human digital twin, is trying to find the correlation with the indoor air quality as well. But I feel like that's something that should be looked more into. But we are still trying to get some conclusions on how they affect each other, because obviously it's not the same, the pilot we have in Valencia compared to, I don't know, the pilot we have in Sweden, as you say, with regards to the weather. And
And it's more complex than that. Of course, indoor air quality is just one parameter.
Yes.
CO2 levels, or actually it could be many more parameters within this, but also the relation of the IAQ to the temperature, to the humidity, so the amount of fresh air you actually let in the building is also related to that.
We are actually analyzing other pollutants, not only these four I mentioned. These are the ones that are being tackled in the building digital twin, but actually the health partners are doing a deeper analysis on how it affects users, and that's why we are doing post-intervention analysis, and we are actually doing questionnaires to the users and try to see if, when we see, for example, a particulate matter increase, they can notice something. We are actually doing some tests with incenses, like with, and we measure and see what happens with that. So we are doing a lot of tests to see user comfort. It's not only, CO2 is high, then we don't care what the user is actually feeling. And we are doing evaluations on that, and we know it's very complex analysis. Yes.
Thank you.
Thank you. So, thank you, everyone.
Thank you very much. We are perfect in time. And so, in conclusion, I don't know if you have other questions regarding the potentiality of digital twin, different application. We have seen building, residential building, airports, or different type of buildings. But so the potentiality of digital twin are very wide, and this process, the digitalization building, is from my point of view fundamental to reach the goal of European Commission, in particular way to reduce the impact and maintain high quality of indoor in buildings. So thank you very much for your presence here, and I hope you enjoy the event, in particular way this paper section and the entire sustainable places. Thank you very much.
Thank you.